All right, welcome back to Math Savvy. We're talking about the max-min acceleration velocity unit. Let's go over what you need to know. Your teacher's going to give you a function, and it's going to be a position function. This is going to be stated in the problem. What you need to know for right now, if you take the derivative of this function, you're going to get the position's velocity function. Now, what does the velocity function tell you? If you take the derivative of the velocity function, or the second derivative of the original f of x position function, you're going to get the acceleration function. Okay, who cares? So now we have to go over what you can find from each of these things. These are all the things that your teacher can ask you about a position function. We're going to cover all of these and what they mean. It's probably going to be best if we just do an example and I can keep this up on the side of it. So the first step to find any of these things is you're going to have to take the derivative of this position function to find the velocity function. So let's take the derivative of this. The derivative of the position function is going to be the velocity function, which a lot of the time is called v of x or v of t, v for velocity. So if we take this derivative, it's going to give us x squared minus 2x minus 8. Okay, so now that we have the velocity function, our first step is to set this equal to 0 and solve for x. Stay with me. So to solve for x here, we notice that this is factorable, and we find that the zeros of this function are x is equal to 4 and x is equal to negative 2. Okay, these are called critical points. So teachers are going to ask you, okay, where are the critical points of this function? The critical points are where the velocity is equal to 0. Critical points tell you where the max and mins of the function occur. They might ask you, okay, what are these critical points? Well, we know that the max and the min are going to occur at either 4 or negative 2. Just a quick side note, your teacher could also ask you, what are the critical values? Critical points and critical values are different things. Critical points, again, is when the velocity function is equal to 0. But critical values is what happens when you plug these x's into the original s of x position function. So if your teacher asks, what are the critical values of this function, you would take 4 and you would plug it in to this function here, and 2 and plug it into this function here. And whatever those numbers are would be the critical values of that function. Okay, let's keep going. So now that you have your critical points, your next step is to draw a number line and write down the critical points on this number line. Okay, cool. Next step is you're going to plug numbers on the left and right of negative 2 and 4, and you're going to plug them back into the velocity function to see whether it's positive or negative. So let's start on the left side. If we plug negative 3 into this velocity function, this is going to remain a negative number, and this is going to be a negative number. Negative times a negative is a positive, so it's going to be positive here. If we plug something in the middle in, let's say we plug in 0, that's going to be a negative times a positive, that's a negative. Okay. Number to the right of 4, let's pick 5. This would be a positive, and this would be a positive. So to the right of 4 is going to be positive. Okay, what does this tell you? These here tell you whether the function is increasing or decreasing. Another word for that is moving forward or moving backwards. So positive is moving forwards or increasing. So this function, s of x, is moving forward from negative infinity to negative 2 and from 4 to infinity. And it's moving backwards from negative 2 to 4. Okay, so we're about to talk about max and mins. How can you tell if negative 2 or 4 is the max? Well, you can tell by these sort of like slopes here. Technically velocity is a slope, right? Because it's the derivative of s of x. So I always like to draw it out. A positive slope looks like this. Negative slope looks like this. And a positive slope looks like this. Well, if we just look at what we just drew, this is obviously going to be the max, and this is obviously going to be the min. So we can tell that -2 is the max, and 4 is the min. So out of all of these questions that your teacher can ask you, these we just answered, and they have to deal with the first derivative or the velocity function. These down here, you're going to have to take a look at the acceleration function. Okay, let's do that. We have to take the derivative of the velocity function to get the acceleration function. So this acceleration function, a of x, is going to equal 2x minus 2. Now, similarly, we set this equal to 0, and we solve for x. So if we solve here, x is going to be equal to 1. All right, so next step, like before, we draw our number line, and we have 1 here. We're going to plug in numbers to the left and to the right of 1 to see if they're positive or if they're negative. So if we plug like 0 into here, that's going to give us -2, negative number. Okay, to the right of 1, let's say we pick 2. If we plug that into here, that's going to give us a positive number. Positives and negatives under the acceleration function are going to tell us if this position function, when you graph it, is concave up or concave down. If it's negative, it's concave down. If it's positive, it's concave up. Concave down looks like this, and concave up looks like this. I like to remember it because you can write concave up like that. Okay, so the next thing that they can ask you is, where is this function? The next thing that they can ask you is, what inflection points does this function have? An inflection point is kind of like the critical point, except of the acceleration part of everything. But it can only happen if these signs are different. So if this was a negative and a negative, which sometimes happens, 1 would not be an inflection point. It's only an inflection point because these are two different signs. So this is positive. If this was positive and this was positive, 1 would not be an inflection point. But in this case, x is equal to 1 is an inflection point. Okay, cool. So the last thing that they can ask you is, where is this function speeding up and where is it slowing down? To determine where this position function is speeding up and where it's slowing down, we have to take a look at both the acceleration and the velocity sort of like lines that we drew. So let's bring this out here, and let's bring this out right here. We have to compare these two timelines. Okay, wherever the signs are the same, the function is going to be speeding up. And wherever they're different, the function's going to be slowing down. So let's look at where the signs are the same. Okay, they're the same here. This is negative, this is negative, this is positive, this is positive. So we know that the function is speeding up at wherever it's... So we know that the function is speeding up in the blue. So if we look at where they're different, we know that they're slowing down here. So, all right, that's literally every single question that they can ask you about this sort of unit. So if you feel good about this, you're going to be fine on your test or quiz or whatever. But let's just review the steps one last time to make sure we're feeling good about it. Okay, so let's just go over the steps. They give you a position function. Just note that sometimes they're going to give you the velocity function and not the position function. In that case, you just don't have to take the first derivative. But they love to be tricky with that. So this is a great way to see how much you remember and test yourself. Okay, what's the first step if they give you the position function? Take the first derivative, velocity. Okay, now what do? You set it equal to 0. And you solve for x's. Solve for wherever it's 0. Whatever x you get that makes the function equal to 0 is going to be called what? Critical points. Critical points, but critical values are something else. Critical values is what happens when you take those critical points and you plug it back into the position function, not the velocity function, the position function. Okay. So you have your critical points. Now what do? You draw your number line. And now you're going to plug in numbers in between the critical points back into the velocity function to see if they're positive or negative. the critical points tell you where the maxes and the mins are. All right, so let's test how much we remember about finding a max and a min. If it's positive to a negative slope, does that make it a max or a min? Well, if this is positive and this is negative, I always like to draw it out. Positive slope is like this, negative slope is like this. That's a max. And then negative to positive, negative slope is like this, positive slope is like that. So that's going to be max, that's going to be a min. Okay, cool. The next thing that I can ask you about is where is it increasing and decreasing? Well, it's increasing or moving forward wherever it's positive on the number line, and it's decreasing or moving backwards wherever it's negative. Okay, what's the next step? That's like all they can ask you regarding the velocity sort of part of it. The next step is acceleration. Set it equal to 0, solve for x. Draw your number line, and then plug in numbers on the left and the right. If it's positive, it's concave up. If it's negative, it's concave down. How are you going to remember what concave up looks like, what concave down looks like? I always like to remember concave up. This is concave up, this little U here. Under acceleration, you can also tell what the inflection points are. So an inflection point is when the concavity changes, when it goes from like concave up to concave down. Like this would be an inflection point right here. And it only happens if these signs are different. So this little point here would be an inflection point because the signs are different. However, if the signs were the same, then this point would not be an inflection point. The last thing that they can ask you about is speeding up or slowing down. You're going to have to compare number lines. So compare a number line. If it's the same sign, it's speeding up. Even if it's a negative and a negative, like if the velocity is negative and the acceleration is negative, even though it's negative, it's still speeding up because the signs are the same. If the signs are different, they're slowing down. Okay, this is literally all of the questions that they can ask you about this unit. So if you feel solid about this, you're good. You don't even need to worry about it anymore. Another video is linked in the bio with just example problems from this, but this was just kind of like steps, overview, crash course. If you want more help, I'm always available for tutoring at math-savvy.com. Check out the links in the bio. All right.